Welcome back, everybody. Today we are on the last part of this chapter and we are going to explore intermediate value theorem. Sometimes it is also written as IVT, intermediate value theorem. Let's understand the statement of the theorem, then we are going to apply this. For a function y equal to f of x, like the one shown here, which is continuous on the interval from a through b. In this interval from a through b, the function is continuous, meaning of that is there is no hole, no break, or no corner. Or in other words, for every point in the interval, the value of the limit is equal to the value of the function. Now, if L is a real number between f of a and f of b, if you look along the y-axis, you can see that along the y-axis here, okay, between f of a and f of b, there is L. Then what happens is for f of a, you have a point A in the x-axis. For f of b, you have a point B in the y-axis. So there will be a point C which corresponds to L in the x-axis. So there's a point C in the x-axis which corresponds to L which is there in the y-axis. That is the meaning of intermediate value theorem. If I want to simplify this, we can write like this. Let's write this. For y equal to f of x, which is continuous on the interval AB, if it is continuous on the interval AB, and we have this condition. Suppose we have f of a is less than L is less than B, f of B. Meaning of that is your L is between f of a and f of b. We can write like this because it is between. We can write like this, or there's a second way of writing this. Or you can also say f of a is the greater, then you have L, then f of b. In either case, whether you take the first case or the second, in both cases, L is in between f of a and f of b. So let's see, in each case, what do we get? For the first case, f of a, you can see this is possible. F of a is less than L is less than b. This is possible if there is a number C in between a and b. So we can write this as a is less than C is less than b. But you can see when you go from here to here, there is f of a. When you go from here to here, that's f of b. That means this one is f of c. L must be f of c. So your L is f of c. So if this is a function, if you plug in c into the function, the result is L. That is the meaning of that, nothing more than that. Here, if you want to do the same thing, it will be A is greater than L is greater than B. Now you can see if you do f of B, you get that. If you do f of A, that is the value. So if we do, this is C in fact. Just give me a second. This would be C. That means f of C must be L. So you can say f of C is L, or L is equal to f of C. That is the meaning of intermediate value theorem. So if there is a function value between two function value, then it corresponds to a value in that interval. That's what it is. That is the intermediate value theorem. That is just the statement of the intermediate value theorem. We are going to look at the example after this. Example, so that the equation has at least one root in the given interval. So here is the first problem, A. So in part A, you have x cubed. Let me write here. Let f of x, I'm going to consider the left-hand side of the equation as a function. Let f of x equal to x cubed minus 4x plus 1. And they have given this interval 1 through 2. So this is your a, this is your b, a equal to 1 and b equal to 2. So if you want to find those values, f of 1, if you plug in 1, let's see what we get. 1 cubed minus 4 times 1 plus 1, which is equal to, okay, if you plug in 1, it will be negative 4. And if you plug in 2, let's try to plug in 2. It will be 2 cubed, I'm plugging in here, or here you can say, minus 4 times 2, then you have plus 1. That is equal to 1. So f of a is negative 4 and f of b is 1. Now, what we have to do is, we have to prove that there is at least one root in this interval. When we say root, that is, for some value of the function, it must be 0. That is the meaning of the root. Or you can write like this. If f of k is equal to 0, then k is the root. K is the root of the equation f of x equal to 0. So if we can get this situation, f of k equal to 0, then we can say that k is the root. So if you look at the condition here, your f of 1 is negative 4, f of 2 is 1. That means f of 1 is smaller. So we have f of 1 is smaller than f of 2. F of 1 is smaller than f of 2 because f of 1 is negative 4, f of 2 is 1. So negative 4 is smaller than 1. So we can write like this, f of 1 is less than f of 2. But also, if you think of 0, 0 lies between these two values. 0 is between these two values. So I can say 0. So actually this one, f of 1 is negative 2, but the condition is still true. So we have seen that f of 1 is negative 2, and then we have a 0, and then we have 1. So this condition is true. Now if we use the intermediate value theorem, what we know is we get f of 1. If f of 1 is less than 0, is less than c, then we know that this is the value of the function at 1. This is the value of the function at c. And this is the value of the function at 2. Okay, this is by intermediate value theorem, such that f of c is 0. Check here, f of 1 is this one, f of 2 is this one, so f of c is 0. If you get the value of the function at some point equal to 0, then that is the root. So c is the root, and c is between 1 and 2. We are asked to prove that there is a root between 1 and 2, and we got it. So there is a root between 1 and 2. So that is the end of this example, part A. Now part B, we are going to consider the left-hand side of the equation as a function. So let's say f of x is equal to x cubed plus x squared minus 2x minus 1. We have to prove that there is a root in this interval from -1 up to 1. So this is your a, -1 is a, b is 1. So we are going to plug in these values. So f of -1 is equal to -1 cubed plus -1 squared minus 2 times -1 minus 1. So if I simplify this, -1, that is +1, +2, -1. These two get cancelled. 2 minus 1 is 1. That's your f of -1. Now f of 1, if you want to look at f of 1, we plug in 1 to this equation again. So 1 cubed plus 1 squared minus 2 times 1 minus 1, which is equal to 1 plus 1 minus 2 minus 1 equal to -1. This is negative, that is positive. That means f of -1 is greater. So we can write like this. Here, f of -1 is greater than f of +1. Right? F of -1 is 1. F of 1 is -1. So this is 1, this is -1. In between 1 and -1, there is a 0. So I can write 0 there. 0 because we are interested in the root. So if it is a root, the value of the function must be 0. That's why. Now, if you use the intermediate value theorem, we get f of -1 when you plug in -1 to the function. So -1, you will get 0 if you plug in c. And you'll get f of 1 when you plug in 1. So this is by intermediate value theorem, such that f of c is 0. F of c is 0, meaning of that is c is the root. C is the root of the equation. So this implies c is the root. C is the root, and this c lies between -1 and +1. That's what we are supposed to prove. It is between -1 and +1. C is the root that lies on this interval from -1 to 1. So we prove that there is a root in this interval using the intermediate value theorem. We are not asked to find what is that root. We are just asked to prove that there is a root, and we prove that there is a root that lies between -1 and +1.